Hey friends, welcome back. In the last video, we understood what caching is, why apps use it, and how it makes systems feel fast. But today we are solving the next important question. If cache stores data, then who puts the data there? And when data changes, how does cache stay correct? Because making systems fast is one thing, keeping them fast and correct is the real challenge. And this is exactly where many beginners get confused. They understand cache hit and cache miss, but they don't understand how data actually moves between application, cache, and database. So today we'll fix that properly. We'll understand 3 famous strategies used in real systems: cache aside, write through, and write back. And by the end, you'll know what each one does, why it exists, its trade-offs, and when to use it. So let's begin. 1. Cache aside. Let's start with the most common pattern, cache aside. This one is used everywhere because it is simple and practical. Imagine a user opens product page 101. Now the application needs product data. What does it do first? It checks the cache. If data is already there, great. Return instantly. Fast response, but if data is missing, now the app goes to the database, gets the real data, sends it to the user, and then stores that same result in cache. So next request becomes faster. Did you notice the pattern? Cache is filled only when needed, not before. Only after a miss? That is why it is called cache aside. The application itself decides when to read cache, when to read DB, and when to update cache. Now what happens when data changes? Suppose product price changes. If old price stays in cache, users will see wrong data. So usually the app updates database first, then removes old cache. Next request fetches fresh data and stores new value again. That keeps data fresh. Why do people like cache aside? Because it is simple. You cache only useful data. No unnecessary memory usage. Great for systems where reads are much higher than writes, like product pages, blogs, profiles, dashboards. But one downside exists. After cache expires, first user may face slower response because that request must go to database. Still, for many systems, this trade-off is worth it. 2. Write through. Now let's move to write through. This one solves a different problem. Problem: stale cache. In cache aside, sometimes old data can remain briefly. Write through tries to prevent that. Here, whenever application writes new data, it updates cache and database at the same time, same operation. So if product price changes to $499, database gets $499. Cache also gets $499 immediately. Now future reads are fast and fresh. That sounds great, right? Yes. But there is a cost. Writes become slower. Why? Because one update is now doing 2 updates, cache plus database. More work. More latency on writes. So when is write through useful? When correctness matters a lot. Where showing old data is risky, like account settings, user preferences, inventory counts, some financial data. So memory hook. Write through equals safer reads, slower writes. 3. Write back. Now the fastest one. Write back. This strategy is optimized for heavy write traffic. Here when app writes data, it writes only to cache first. User gets quick success response. And database update happens later in background. That means write feels extremely fast. Why? Because cache is usually in memory. And memory is fast. This is powerful in systems with huge traffic, like counters, analytics, logs, rapid updates. But now comes the danger. What if cache crashes before background sync happens? Then latest data may never reach database. That means data loss. So write back gives speed, but requires careful engineering. Queues, retries, persistence, recovery systems. So memory hook, write back equals fastest writes, highest risk. Which one should you use? Now the real interview question. Which one is best? Answer. There is no universal best pattern. Best depends on your system needs. If reads are high and simplicity matters, use cache aside. If consistency matters more than write speed, use write through. If write performance matters most, use write back. Always choose based on trade-offs. That is real system design thinking. Final summary. One line each. Cache aside is simple and popular. Write through is fresh and reliable. Write back is fast and advanced. If you understand these three patterns, you now understand a big part of real-world caching systems. If this video helped you, like the video, subscribe to the channel, and share it with someone learning backend or system design. See you in the next one.